Good day to our lecturer and friends. Today, our group will present our database project for Mixue. Allow me to briefly introduce our company, Mixue. Mixue is a small dessert business established in 2024 by Ms. Alisa Uhara. The shop specializes in ice cream and also offers milkshakes, croffles, and cakes. Customers can choose from different flavors, toppings, cup sizes, and combo sets. Mixue provides dine-in, takeaway, cashless payment, and online delivery services through Foodpanda and GrabFood. The business was started after the COVID-19 pandemic to recover from financial difficulties. As it's received many recognitions, managing customer orders, inventory, suppliers, and sales manually became more challenging. Therefore, Mixue plans to develop a database system to organize business information more efficiently, improve daily operations, and reduce data redundancy. Next is our organization chart. At the top of the organization is the founder, Ms. Alisa Uhara, who oversees the overall business operations, monitors the company's performance, and makes the final business decision. The finance officer, Bibi Nadia Husna, is responsible for managing sales records, cash flow, payments, and preparing financial reports. As the store manager, my role is to manage the daily operations, supervise employees, and ensure that the business runs smoothly. The customer service officer, Nabila Khairunisa, handles customers' orders, process payments, and assists customers with their needs. Lastly, Andrea Estabella is in charge of inventory and supply, where she manages inventory records, monitors stock availability, and communicates with suppliers. In our daily operations, customers place orders at the counter or online. Cashiers then record the orders and payments into the system. Finally, the kitchen staff prepares and serves the items. Management, including the founder, finance staff, and store manager, will monitor these sales and operational reports. To support this, our database manages four main data components. First, staff data for profiles and schedules. Second, customer order data for transaction details and total prices. Third, product data for menu flavors and prices. And fourth, inventory data to monitor raw material, stock levels, and supplier information. Mixue previously faced three major problems. First, using physical logbooks caused data loss and order mix-ups. Second, manual backups in Microsoft Excel led to human errors like mistyping stock labels. Third, sales data was isolated in those receipts, making financial reporting unreliable. To solve these problems, we proposed the Ice Cream Sync database system. This system eliminates loose paper logs and manual Excel spreadsheets. It is highly efficient at storing and managing real-time data, increasing overall operational efficiency and helping management track sales and customer order data seamlessly. Next, I will pass the presentation to Nabila.
Thank you, Aviona. Our system targets three core objectives. First, to develop a database system that improves efficiency and speed up order processing. Second, to eliminate manual record keeping and data duplication. And third, to design and organize database to manage customer, product, order, and inventory information systematically. Then, the core modules needed include customer detail like name and phone number, order logs such as order ID, date, product flavor, quantity, total price, and payment method, as well as staff names and sales reports. For our conceptual design, we identified the core entities. First, customer store, customer info and contact detail. Orders record the transaction date, time, and total amount. Product stores menu item details like category and price. Lastly, item acts as a bridge entity to link orders and products while storing the purchased quantities. Next, we have staff to record employees' details, supplier for raw material replenishment records, and inventory to track stock quantity and availability. Ingredient links product to inventory to show the exact item needed for each menu, while payment records transaction details. Our database follows strict business rules. A customer can place many orders, but each belongs to one customer. An order must contain at least one product. One staff processes many orders and one supplier supplies many inventory items. Crucially, inventory stock is automatically reduced when an order is placed. I will now hand over to Bibi Nadia Usna.
Thank you, Nabila. This is our relational schema showing the mappings. It translates our business rules into structured relationships, such as the one-to-many relationship between customer to orders and staff to orders, which ensures data consistency. Let's look at the data types and key constraint. For the staff entity, which is staff ID, is the primary key using varchar 10 alongside attributes like staff name and schedule. For the customer entity, customer ID is the primary key supported by customer name, phone number, email, and address using varchar. For the product entity, product ID is the primary key, and the price use decimal 52 for exact monetary values. For the order entity, order ID is the primary key. Order date uses date time, while customer ID and staff ID are placed as foreign key to establish relations. For the bridge tables, order underscore item use a composite primary key of order ID and product ID. Similarly, ingredients use a composite key of product ID and inventory ID. The inventory and supplier entities also use dedicated primary keys and foreign keys to complete the relational infrastructure. This is our finalized entity relationship diagram, ERD, displaying correct cardinality and strong referential integrity. For DDL execution, we run create database ice cream sink to build our environment and use drop database ice cream sink to reset or delete if it necessary. That's all from me. So I will pass to my teammates, Andrea.
Thank you so much, Bibi. In our DDL phase, we create independent table first. As shown, we run create table commands for staff, customer, supplier, and product, establishing their primary keys and text data types clearly. Next, we create the dependent tables, order item, ingredients, orders, and inventory. Here, we use foreign key and references constraints to enforce relational integrity across all connected tables. For basic DML queries, our first statement selects specific columns like order ID and total price from the order tables. The second statement queries such as staff ID, staff name, and schedule from the staff table. The execution outputs are displayed below. Next, Alisa will present our next discussion.
Thank you, Andrea. Now, I will explain the SQL statement to list the significant information from the table that has relationship without using join clause. Even though we are not writing the join keyword, the tables are still connected using a condition. In this query, we select customer name from the customer table, order date from the order table. This relationship between these two tables is establishing using the condition, which is customer.customerID equals to orders.customerID. This ensures that each customer is matched with their correct order. Finally, the result is sorted in ascending order based on the order date, so we can see the earliest order first. For the next SQL statement, we use the join clause, especially a left join. This query retrieves product name, flavor, and also quantity from the product and order item table. A left join ensures that all products are displayed even if there are no matching record in the order item table. The relationship is defined using the product ID equals to order item product ID. Then the result is sorted in ascending order based on the product name. So the query helps us to understand which the products are ordered and their quantities. The second SQL statement uses the inner join. This means only matching record from both tables will be displayed. The query select customer name, order ID, order date, and also total price from the customer and order table. The relationship is again based on customer.customer ID equals to order.customer ID. Only customer who has placed order will appear in the result. The data is sorted in ascending order by the order date, making it easy to analyze the order timeline. Now, I will pass to Andrea to explain the SQL.
Thank you so much, Alisa. Now, let's look at how our database handles data filtering using specific SQL commands. For our first slide, we are using a comparisons operator. First, we wrote a select statement to pull data from the orders table. By using the greater than operator, we filter for orders where the total price is more than 15. As shown in the result table, the query successfully found 9 records. So every order here ranges from 18 ringgit and 70 cents down to 16 ringgit and 80 cents. This proves that our database constraint is working perfectly. Next, let's see how we can group items using the in clause. Instead of writing multiple or conditions, we use where staff ID in. This allows us to quickly grab transactions handled by cashier S001, S002, and S005. We also added order by total price to sort the values from highest to lowest. The result grid clearly displays this descending hierarchy. It starts with a top transaction of 20 ringgit and 70 cents handled by staff S005 and goes all the way down to a cash payment of 11 ringgit and 80 cents. Finally, let's how we search for specific text pattern using like clause on the next slide. Now I'm going to show you the second SQL statement using the like clause that also in descending order. So here we want to search our customer table for name starting with the letter N, and we use the like and syntax where the percentage sign act as a wildcard. Then we sorted the list by customer ID in a descending order. As displayed in the table, our database accurately found 2 matches, Nurul Huda and Nur Aisyah. Because of the descending sort, customer C010 is listed first, followed by C004. This concludes our SQL query demonstration. Now, I will hand to Nabila for our next section.
On to the next one. We have the column function. In this section, aggregate functions are used to perform data analysis on the database. The first SQL statement calculates the total sales from the all orders using the sum function. This helps the management to understand the overall revenue generated by the Mixu ice cream sync database system. The second SQL statement calculates the average price of all products using average function. This allows the company to analyze the general pricing of menu items offered in system. The next one is having clause. In this section, group, by, and having clauses are used to filter group data based on specific condition. The first SQL statement identifies products that have been sold more than 3 units. This helps in identify the most popular product based on customer demand. The second one, SQL statement calculates total spending for each customer and display only those customers whose total spending is more than 15. This allows the company to identify high-value customers. The last one is subquery. In this section, a subquery is used to compare data between one same database. This SQL statement retrieves product name and prices where the product price is higher than the average price of all products. This helps the company to identify a premium price item in the menu.
That concludes our presentation. Thank you very much for your time.